Problem number 3 tells us to identify the asymptotes for y equals 1 over x plus 4 minus 5. This one's a little bit different. We don't normally have, or we haven't seen many that have an additional constant added or subtracted on the end, but that's okay. We'll see exactly how this impacts the graph here in a moment. Typically, constant values at the end of a function are only going to shift a graph up or down vertically. Okay, so they're not going to shift it left or right, just up or down. Now, the vertical asymptote, we talked about this in the last problem, that's going to be anything that makes the denominator only of the rational expression actually equal 0. So if we look at this denominator of x plus 4, the 0 here would just be negative 4, because negative 4 plus 4 makes the denominator 0. Since we can't divide by 0, that gives us our vertical asymptote. So we would say x equals negative 4. If we use that for x, we are going to get a vertical asymptote because that's a 0 in the denominator, which is not allowed. Okay. Now, in the last problem, we talked about horizontal asymptotes, and we said that just graphing it and identifying the horizontal asymptote is going to be the quickest way. But to just understand the math a little bit better, I'm also going to explain it, how to do this manually, okay, without looking at Desmos. But let's start with the Desmos option for it first, in case that's as much as you want to see. Let me switch back to Desmos. And I'm going to clear out the equations that were there from the last problem. And we're going to type y equals 1 on the top, x plus 4 in the denominator. Then I'm going to hit the right arrow key and type minus 5. So looking at this, let's zoom back into my home button. Okay, it looks like I'm going to have a horizontal asymptote that's negative. If I click and drag, I'm seeing negative 4.9 something. And then on the other side, negative 5.1 something. So these look like they're getting closer and closer to negative 5. Okay. If I zoom out a little bit, I can actually see a line on the graph at negative 5 that appears to be perfect for our horizontal asymptote. So we're going to say y equals negative 5. Yep, that is the horizontal asymptote. So I'll switch back over. We'll write this down on the paper, and then we'll talk about how we can calculate this aside from Desmos. So horizontal asymptote will be at y equals negative 5. So with this one, I want you to notice the degree of our rational expression that we start with here. In this case, I have a degree of 0 on the top because there are no x's. Okay, so this is a constant on the top, which we consider degree 0, like x to the 0 power. In the denominator, we have an x, but there's no visible exponent, so that means it has a degree of 1. That's x to the first power, which makes this a linear. Either way, regardless of whether you know the names or not of constant and a linear, we can tell that we have a higher degree of x's on the denominator, in the bottom, than we do on the top. Whenever you have a larger degree in the denominator, that typically gives you a horizontal asymptote of y equals 0. Okay, so this part right here has a horizontal asymptote of y equals 0. That's really just the x-axis on the graph. We would see the arms get really close to the x-axis on the left and on the right. So where did we, if we just said that this part is really a horizontal asymptote of 0, where does the negative 5 come in? Well, that's because this minus 5 on the end just slides the whole graph down 5 places. That means it also slides the horizontal asymptote down 5 places. So instead of a horizontal line on my graph at y equals 0, now the horizontal asymptote goes down 5 units, and the arms of the graph will get really close to negative 5 instead. Okay, so that's the impact that this has on the graph. If I go back to Desmos for 1 second, I can show you that change actually happened live. So if I take the minus 5, look at this. The graph now has arms getting really close to the x-axis. That's y equals 0. But if I put that minus 5 back, everything on the graph shifts down 5 places, and now my y equals equation, my horizontal asymptote, would be at negative 5. Okay. So that addresses our horizontal asymptote and our vertical asymptote for problem number 3.